Okay, so welcome back, and now we're going to do another theorem. We're going to introduce another theorem, and this takes the general case of logarithmic functions and exponential functions. So now we're going to turn our attention away from the natural exponential, the natural bases, the natural exponential function and the natural logarithmic function, and focus on general exponential logarithmic functions. And so we're going to see, again, a little bit of difference. There's one more piece we have to add when we're talking about general cases, okay? So notice here, in Theorem 2 it says let b be greater than 0, b not equal to 1. Of course, that's what we usually have for the definition of any logarithmic function or exponential function. And let g of x be differentiable, be a differentiable function. The first result, the first case is if y equals log base b of x, so any general logarithmic function, then the derivative of y is equal to 1 over x, okay? And also divided by the natural log of b. So there's that new piece there, the natural log of b, okay? So remember, if this was a natural log, it would be log base e of x. Well, what's the natural log of e here? 1. So it goes away. So that's why in the special case of the natural logarithmic function, we don't have this natural log of b because the natural log of e is just 1. So it just reduces to 1 over x. Okay, so this is more general, okay, for this one. Okay, now, what if we have some other function besides x? So let's do more generally. So more generally, if h of x is equal to log base b of some function, g of x, and again, g of x is differentiable, then for all x, such that g of x is positive, then we have h prime of x is equal to g prime of x over g of x times the natural log. So again, so in other words, this is introducing the chain rule. So if you can see it more if you realize it's 1 over g of x, right, times g prime of x, right? There's that part we saw before. Now the new piece, because it's a more general case, is 1 over, we're multiplying by 1 over the natural log of b. Okay, so that's that new piece we didn't have before. Okay, but that's because now we're dealing with not the natural log, but we're dealing with any log function. Okay, now case 2 is if y equals an exponential function, okay? So instead of the natural exponential function, now we're turning our attention to the general case of any natural log function. Well, if that's the case, then the derivative of y with respect to x is equal to b to the x times the natural log of b. Okay, and again, in the case of the e to the x, the natural exponential e to the x, well, what's the natural log of e? 1. So it just became e to the x. So that's where we get the result that the derivative of e to the x is equal to e to the x. Okay? So again, this is a more general case. But even more generally, right? So what if instead of x, we have some function where we have b to the g of x? Well, then we have to use well, not the chain rule, but remember, we're going to multiply by the derivative of the exponent. And so notice how the derivative of h prime of x is b to the g of x, so it repeats just like before. So this is what we've seen before, but the other new pieces we're multiplying by the natural log of b. Now, notice something with log functions. This piece is the same, but then we're dividing by the natural log of b. Whereas with the general exponential case, everything is the same, right? Except now we're multiplying by the natural log of b. So that's the only piece you have to remember when you're applying it in the general case. Okay? So again, let's do some examples and we'll go from there.